Alright, so in this video we're going to learn about SQLx. Before I do that, let's just explain what SQLx is. SQLx is not an ORM. It is a database driver, and therefore once we start writing code, it's all going to be in SQL. So we'll be writing selects, updates, deletes, inserts, all that good stuff. And SQLx additionally is very simple. The interface is pretty bare bones and easy to learn, unlike a real ORM, which has a lot of custom syntax specific to the way that they do inserts, updates, and deletes. So the first thing that we need to do is we need to get a database up and running. So we're going to run this Docker command based upon this Docker compose file. So in this lesson, we're going to learn with the Postgres database. On the default ports, everything is tester. And then once this deployment happens, you'll see DB data as the folder in your project folder. So if we deploy, we should see it install as SQLx, the project name. And then, subsequent to that, we need to get our database and the tables and schema set up. So that is inside of SQLx, that is called a migration. So even though it's a database driver, a lot like other ORM-based systems, it has a migration system that allows you not only to do that initial setup of your database and set up its schema, tables, and all that good stuff, but it allows you to update that and modify that over time. So in other words, the first time that you get it up and running or migrated is not the last time you can touch the database, but you can make subsequent changes to the database. So you need to first make sure that you have the SQLx CLI installed and Postgres installed, because we need the PSQL CLI, the Postgres CLI. So since this is an intermediate course, I'm going to assume you guys already know how to install this stuff. And the first thing that we're going to do is we're going to create the database itself, just an empty database. And to verify that that happened, we're going to use PostgreSQL or CLI. And as you can see, there's an empty database. The username is tester. And then I typed in tester as the password. So then after that, we need to create our database schema. So the way that I'm going to do that is I'm going to create, in order to demonstrate the modifiability of the schema, I'm going to create a migration independently, run that, have everything up and running, and then I'm going to modify it subsequent to that. So we copy the SQLx migrate add profile table, and then that gives us inside of the migrations folder this file. So basically this is how SQLx keeps track of the set of related changes that it has made over time. So this is a Unix timestamp. And then whatever we put in here, whether it's one single table or multiple tables or whatever it is, this is considered one set of schema changes. And then as our app changes and our database needs change, we can add subsequent SQL migration files to either add additional tables or make actual schema changes. So I'm going to go ahead and just copy the code that I have in the finished project. And I'll just paste that in here. So all we're doing is we're creating a simplified profile table. So the primary key, some timestamp fields, and username and full name. This is just a very simple table. And then I wanted to pre-populate with some data. So that's why this is here. And then, as I said, this is going to be the first of 2 migrations that we're going to do. So once this is set up, this migration file, then we need to actually run the migration. So you can see the matching number right here to what was run. So then if we go to pSQL again, we should be able to see that we just created profile table and it has some default data in there. So then now I'm going to create a secondary migration, and you already saw that the first migration is finished. It's done, it's set in there, and yet we are going to be able to modify the database once again with another table, and this time one that has a foreign key relationship to profile. So in other words, this message belongs to a certain user. And then we'll have a little bit of default data as well. So I save this file, and then we'll run the migration again. SQLx migrate run. So then if we go here again, we see our default data. And again, this is where all the database files are living. So then now we can actually write some code. So this is what the query or syntax looks like. There's really not much to it. So beyond that, we do need to indicate the actual type that we want to map to. And then in here, we put in whatever our query is supposed to be. So what this means is, well, we have our regular Postgres SQL query, but we're saying that the first parameter that I pass in should be mapped in here. And then if we have secondary parameters, then we put it in like this, but in this case, we're only going to have one. And then over here, as I said, we need to indicate what type is coming back or what type should be mapped to, and we're going to create this in a moment. And in this case, we're indicating the database, but because we don't use this directly, I've chosen to just ignore it. And the parameter is syntaxed in this way. So if you remember the call that we made, we have this data that we pre-inserted. So I'm just going to pick whatever, number 2, let's say. So we put in ID number 2. And then we have different ways of actually fetching the data. So we can get all of the data. We can get just one piece of data. We can do a dynamic, a weighted query. We can account for the possibility that the data that we want is not there and therefore optional. But in this case, we're just expecting one single item to come back. okay? And then all of these queries are going to be awaited because they're asynchronous. And then let me just create a variable before I create this type. So then the type is again mapping to whatever's coming out of the database table that we called profile. And all of the fields that I create in my type need specific field types in order to map properly with the field types in the database. So in the case of timestamps, right? And then the big serial primary key, we need an I64 for the primary key, and we need this off of the Chronos crate for the timestamp because it is UTC, the one that we're using. I'm going to ignore the other field. And then any string type is basically string. So then, in addition to that, we need to derive from some things. In order to enable or allow this automatic mapping to happen, we need to derive from the from row trait, which is part of SQLx. This is what's going to allow this correct mapping to happen. And then we also need to make it deserializable so that it can go from that database type and then be deserialized into our Rust type, right? Let's enable debug so we can print it out. Let's get rid of some of these squiggly messages. All right, so this is what we have, and then we have some result. And if this is working properly, then we should be able to get back whatever the result of this query was. So as you can see, some profile item came back, the one with ID 2, and it has a username of John and then John White. So if we look at that, we can see that that's the second person. Okay, let's continue. So as I mentioned before, it's just super easy to query with SQLx. So what I'm going to do this time is I'm going to show how we can create an insert of data, right? So this time what we're going to do, actually let me show you the query first. Let's insert into our messages table. So we have our user ID, we have our body, and then we have our likes. Let's do it this way. So as I mentioned before, when we have multiple parameters, we just do them sequentially, and that takes care of that. So we have our user ID that we're going to be associating to our message. We have a message body or the contents, and then we have the likes count in here. Now in Postgres, this is a Postgres feature, but we can, when we insert something, we can actually return one of the created fields out of it. So then I want to return the ID after I create this, assuming it's successful. So we had queried the profile with number 2, so we'll do that for this insert. And then I'll put in classic hello world. And then let's say this person got 10 likes. So once again, we're only getting back one thing. We have to await it. Just make sure we don't have any issues. Right. So what I need to do is I have to create what's coming back, right? So in this case, we're only getting back that one ID, which is of type I64, because that's what a big int primary key maps to. And then we need to do the from row again and deserialize. Let's make this debuggable. Open this up. So again, we're just going to see what happens here. So entity ID of 3. And that's because we had pre-populated with 2 before. So if I search again, then we should get hello world. All right, so then for this final one, let's get rid of this guy. For this final one, let's see what it looks like to do transactions. So in the case of transactions, actually no. In the case of transactions, we got to make the transaction mutable. So we begin by taking the connection, beginning a transaction, awaiting on it, and then it's a result, so we need to unwrap it, and then we get this transaction type come back. And then what happens is our queries after that actually use the transaction as the connector instead of the actual connector itself. So in the first case, let's do another insert. So let's do insert into profile. So it was username, full name, and we'll do $1 again, $2 again, and we're returning the ID. So I'm going to use something called faker. And what faker is like if you've ever used Node or React, there is a library called faker that kind of automatically creates random usernames and field data on your behalf. So fake is the exact same thing, but on the Rust side. So let's just go ahead and use that. And then to populate the full name, I'll use that. Turbo fish again. So now we have our two, whoops, what's this? We have our two parameters, right? So then, as I mentioned, we need to use the transaction in order to get this to be atomic, right? So that's why it's mutable, because it needs to be able to roll back. So we're going to do this insert first. And then after that, we're going to do a query or a select. Let's just copy this. But we're deliberately going to enter in an invalid value just to see, and then trigger a rollback just to see what happens, right? So in this case, since we're dealing with the profile, right, we need to put in the profile there. So in the first case, let's see what happens if this is done properly, meaning with a correct value. So in this case, we're only getting back 1. Just make sure everything is okay. Let's get rid of this. Okay, so what I want to do is I want to match on this, right? Because this is a result that has come back. And I want to say, okay, if this worked, let's just print it. And then let's commit it so that everything gets accepted. But if it doesn't work, let's do a rollback, right? Check that real quick. So what's going on here? And this font is too big, so I'm going to shrink it a little bit. So we start at the top. We've declared that what we're about to do is going to be multi-part, and we want the entire set of things to either completely succeed or completely fail with no middle ground. So we've created a transaction in order to do that. And in order to make use of the transaction, all of our queries have to actually connect and fetch with the transaction and not with the connector. In addition to that, we've gone ahead and we've done our first transaction, which is an insert. So we're creating a new profile basically, and we're returning the ID, and therefore the mapping or type mapping is entity ID, and then this thing, if it's successful, it will give us back the ID, and then we're going to take that, whatever the ID may be, and we're going to pass it into a query to retrieve that profile data of the one that we just inserted, and then we're going to check over here that that call was successful, and if it was, we're just going to print it out. But we're also going to commit it so that we can make sure that everything completes as a whole. And then if for whatever reason it failed, we're going to indicate that, but we're also going to roll back such that not only did this query, let's say never happen, but also the insertion never happened, right? So in this first case, we're going to go with the success case. So if we run this, so now we have a 5th profile, and we've fallen into this success portion, meaning our item was committed, right? And then we can verify that by going in here. See, this is our old query. We only see the 4th item in profile. So if we search again, then we see this 5th item, right? Now, if I go in here, and then I put in some nonsense number, let's comment that out, right? So clearly, we haven't even reached this level of primary key yet. So it should go in here, it should roll back, but it should also roll back the insert as well. Right? So then we have our failed message indicating that nothing was inserted because we couldn't find anything, right? So that's our error situation that we've defined. So it should have rolled everything back, and we shouldn't see a 6th profile item, right? And we don't. So yeah, that's it. I'm sure it's kind of surprising, like how easy it is to query with SQL syntax, with SQLx syntax. This literally is all there is to it. I mean, once we start building the app, we're going to start, using the different types of fetching schemes for getting things like collections of elements and stuff like that. But nevertheless, for the most part, this is literally all there is. So you can just take your existing SQL skills and without having to learn much of anything at all, just get productive right away. So SQLx is really awesome.